Okay, so, and for some reason, this is difficult for people. And I'm not sure why, because it's just straightforward 8th grade geometry. But it's applied to something with a little extra stuff, okay? So it's based on the simple 8th grade geometry. That's what people seem to keep not using, okay? Because again, 8th grade geometry is not much of a geometry course, I'm afraid. SOL driven, can't do it. Okay, so anyhow, again, we have the situation. Tube has a cross-sectional area of 0.07 square centimeters. Each gram occupies 1 cubic centimeter. 12 grams flows into an empty tube and 48 ticks. And what can we then conclude? Okay, now, we could just stop there, because there's all of our information. The next thing's a question. What can we determine from all this?
That 0.2.
At this point, yeah, at this point we can see now we know what volume was filled. In 48 ticks. At this point we know something. Okay, so we can kind of say, okay, right now I know something. I'm not even going to read the rest of the problem because I know I can use this to figure some stuff out. Okay? And if you figure out what you can figure out from what you have already, then you're going to figure out the answer to this question without even reading the question, which is a valuable thing to be able to do, because if you get to here and you say, okay, now I know I can figure, I know the volume and I know the cross-sectional area, so I can find the altitude, which is the length of tube that's filled by the water, right? Make sense? So if you read the question, that can actually confuse you. That can also guide you. And, kind of be aware of that, though. A lot of times, you just want to forget what the question is and look at what you've got. Okay? Especially with a challenging problem. What have you got and what can you do with it? Well, what we've got is this, and what we can do with it is we know how much volume was filled in 48 ticks. And the cross-sectional area of the tubal. And if you know that, and you understand a little bit about geometry of volumes, which again seems to be something that nobody seems to understand as well as they should, okay? Just one of the big deficiencies, and I've been yelling and screaming about basically eliminating geometry from the curriculum for at least a decade, okay? It's ridiculous. So people don't know how to think in terms of volumes, and then you take a calculus course, which often has a lot to do with volumes, and you get what we get. People that can't deal with the whole concept of volume. So you want to fix that. And you're not going to fix it overnight, but at least get this one principle in your head that cross-sectional area times altitude is volume when you have a uniform cross-sectional area. Okay? Something you should kind of theoretically have been thinking about for a little over a week, because we've been talking about it for a little over a week, sporadically. We've been talking about a lot of things. You're going to miss some stuff. It's natural to miss the thing that you're not as well prepared to think about. Okay? Okay. So that aside, we know the volume was filled in 48 ticks and the cross-sectional area of the tube. So we can find the length of the filled part of the tube, can't we? Okay? Now in a minute we'll talk about how Corbin approached it. Okay? Because what Corbin did was he basically said, okay, I know 1/4 gram flows in 1 tick. Well, you could find what length of the tube 1/4 cubic centimeter fills to, right? Got to be between 3 and 4 centimeters, because the cross-sectional area is 0.07 square centimeters. And that's a really good way to approach it, but I didn't want to go that way because that involves this division, which has its own meaning and doesn't start with the critical idea that people don't pick up on typically in this situation. Okay? And incidentally, people had trouble with this 25 years ago, before geometry got dumbed out of the curriculum. So maybe there's just something that's hard about these ideas, okay? But they're really important ideas, and you got to put them together. And you'd be much better off if people taught this rather than teaching a page full of formulas you don't even have to memorize.
You could get the answer to the length multiple different times, but you can get it 2 different ways.
Yeah, I mean, your way of doing it is say, okay, let's figure out what happens in 1 tick.
You can,
Because we're asking a question about something that happens per tick, right? That's a totally natural thing to do. Again, I wanted to start here because, first place, it's easier to visualize a longer piece of tube than a shorter one.
you can do it the way I did it. Was you divide a. What did I do?
Well, let's
Sorry,
not go there yet. Let's finish it from this premise.
Can you just let me-
And then we can quickly look at what you did, because everybody will understand that once they understand this. Okay? I wanted to go directly to the difficult part, and let's do that. So, okay, so we can find the length of tube filled in the 48 ticks, right? Okay? So once we find that length, what are we going to do with that? And don't say, Corbin. You know, but, huh?
Multiply.
Multiply what by what? Don't give them any hints. We want people to think through. Okay?
Never mind, I don't know how you're doing it. I did it a different
It's
way.
okay.
We know what volume is filled in 48 ticks.
You have to divide.
Divide what?
48.
12 by 48.
Huh?
12 by 48.
No.
The volume divided by the area.
Well, that's the way, well, yeah, if you divide the volume by the area, you get the length of the tube, right? So we're going to assume you've got the length of the water in the tube. So I said, once we've done this, and this says we can find the length of the filled part, so let's assume we've done that. At this point, we're developing a strategy, and we're not actually going to do the calculation, although maybe we will, and that'd be fine.
The length of the.
We're looking ahead to what's the next thing we do.
The length of the filled part.
No. Let everybody else think it through. You know, I know you know. You knew as soon as I wrote the problem down. I want everybody else to think it through. So if we know the length of the tube that's been filled, how do we find how fast the water moves in that tube? In other words, how far it goes per tick. Well, how far did it go?
12 grams. Or 12 cubic centimeters.
12 grams is not a measure of how far. That's you can't say something went 12 cubic feet. Some things don't go cubic feet. Now, things might occupy cubic feet, but they don't go cubic feet, right? Okay, so not a bad attempt, but
From the end of the tube to the other.
okay. Now,
How
I'm
far
going to go ahead and put a number down here, because I don't know that people are focusing on the fact that you know the length of the tube that got filled at this point. Length of the tube that gets filled in 48 ticks is going to be about 170 centimeters.
So using that number,
Where'd you
Okay.
get that number?
Huh?
Well, divided by 0.07.
I'm not going to tell you where he got that. Geez, we got this and we got this. You can figure out where we got it.
using that number.
Now, I'd be glad to
how do
tell you, but I'm not going to tell the class. Now, okay?
Using that number, how do you figure out how many centimeters it filled per tick?
You just gave it away without making people think. It's okay. It's late, people are having trouble
I
thinking
still
anyway.
ain't get it.
Okay?
You're not alone.
Okay, look,
My brain's.
So divide that by,
you filled 170 centimeters of the tube. As it was filling, water moved along the tube. How far did the water move along the tube?
well, each gram occupies 1 centimeter.
How far did water have to move along the tube to fill 170 centimeters of the tube?
170.
It had to move 170 centimeters as the water was filling it. So now you've got all 12 cubic centimeters in it, right?
Mm-hmm.
So how fast was the water moving as it filled the tube?
Would you times that by the flow?
About 14.
You
Or
divide-
divide
I don't want a number, I want a process. What do you do?
Would you divide 170 by 12?
No?
170 by 48.
48 ticks. We're talking about how far it goes per tick.
Thank you.
So you have to visualize that there's 170 centimeters that gets filled in 48 ticks.
Corbin's like,
This far, dude.
I'm like,
How
"What?"
many ticks is this far?
48.
And how many ticks does it take to fill 170 centimeters?
48.
So how do you figure out how long it takes to fill 1
48
tick?
divided by 170, or 170 divided by 48.
Yes.
It was a vague question.
You just chop this 170 centimeters into 48 pieces, right? You understand why I say a good picture can be helpful?
No,
Okay, also,
I didn't get the picture part.
being able to do problems that you haven't been spoon-fed and regurgitated is helpful. And that's where our system is a little bit behind the world. Okay? Significantly behind. Okay?
Question mark, exclamation.
Which is why we're doing this course the way we're doing it. Okay? So the fact that you have trouble thinking this through,
Exclamation, exclamation.
Question mark, question mark.
you've probably been too busy doing manipulations that people know are going to occur on the SOL and not busy enough thinking through challenging problems. Okay? And that's all there is to it. So just, again, I'm not saying there's anything wrong with you, but there's obviously quite a bit right with everybody. But challenge yourself to do that, okay?
Oh yeah, prepaid.
Okay, so now the way Corvin approached it was what?
Corbin.
He just went down to what happens in 1 tick, right? Rather than figuring out what happens in 48 ticks, which is 170 centimeters of the tube gets filled, he said, well, in 1 tick, you're going to have 1/4 of a centimeter that gets filled, right?
Mm-hmm.
So he immediately broke it down to, Corvin. Let's put Corvin's name on this. He deserves credit. That's a bad color. Can't read it. Where are all my? Okay, I've got a pack of colored chalk. Where's my pack of colored chalk? I brought one out here. Here it is. Okay.
Could I go up there and show how I did it?
No.
All right.
I mean, I would say yes, but
Not
limited
enough
time. And I want to make sure the handwriting is such that nobody can read it.
Right.
Okay, so Corvin, in terms of the way I explained it here, because I don't want to switch gears to the way Corvin might explain it, although his way is probably every bit as good as mine. Okay?
It's Corbin.
Huh?
It's
It's
Corbin.
Corbin. Corbin.
That's what I wrote.
B, not V.
B.
Like
not
as in
D.
boy,
As in
Bat.
boy.
ball.
I'm thinking vectors, Corbin. Who the heck is Corbin? Okay, I can't hear the difference between a B and a V, so, you know, I can spell it any way I want. And how many times have I read, and I'm really pretty good with visual, I mean, you know, I spell really well.
I thought he'd be
Okay.
Corbin, not Corbin.
Uh,
Corvette, Corbin.
Okay,
What's up, Corvette?
so here's Corbin's picture, and this is in one tick he gets 0.25 cubic centimeters, because in 48 ticks he got 12, and that's an obvious thing to divide, right? Okay. And then he just figures out the length of this, and that's how far it flows in a centimeter, right? Now every centimeter at this cross-sectional area, you get another 0.07 cubic centimeters, right? So you're going to get 0.07 in the first second. By the end of the second second, it'll be 0.14. Third second will be 0.21. Fourth second will be 0.28, right? Can you visualize that? Okay, so I'm not going to draw it because of time. I'm going to give you a break here. But we get the idea.
Mm-hmm.
Divided 0.25 cubic centimeters.
So
by
if you
0.07.
divide this by 0.07 cubic square centimeters, you're going to get something between 3 and 4. Because you count the 0.25 by 0.07s, right? If you understand volume relationships, which you really want to work on. It's really important. As I said, you know, my grandson had to take a spatial reasoning test. I didn't know they did that. And partly because most of the people I know that go to tech are my engineering students. They're going as juniors and don't have to worry about that because they've had the engineering courses that taught them that. I think it's a good thing. Spatial reasoning is not a bad place to start, okay, to understand volumes and picture things. And picturing is critically important in almost any scientific field or scientific related field, okay? It's important in the medical field too. You got to look at these diagrams and visualize what they're telling you. You know, try to read an X-ray someday. Ho ho. You know, I understand all the wave stuff. I doubt that I could learn to be a good X-ray reader. Special skill. I'd probably be able to read them, but not well. Okay.